All right, so are we all set with this? Any questions? I mean, am I doing any physics or am I doing math here? This is all about your Calc 1. I don't know, Calc 1, maybe Calc 2. Right, so my physics ended once I found the net force. And now I am looking at I mean, you are using your knowledge in applied side of the math that you have learned. I mean, what you learned before maybe was not very useful, maybe up until now. So you are using what you learned in the math class here. So you can find that, and then so you can find the position using the substituting the value for D. And then once you find the position, the last part of the question is what are the magnitudes of the minimum and maximum magnitudes? Of course, the minimum magnitude is 0 because the two forces cancelled out. And to find the maximum magnitude, you substitute the value of x that you get here in your original equation of F net. Our F net equation is right here. F net equation is right here. So you have to substitute the value for x square root d square over 2. And then here you have the Q3 and Q1. Those values are given to us. So you basically substitute for everything and find the net x, which is maximum at that particular x value. And that's how you complete this problem. Now I want to do another problem. All fun. This one. They are different. That's why I picked them. Oh, okay. So before I do that, before I go anywhere, how can I change the problem that we just discussed and give you in the exam? What if I arrange the problem like this? I place the Q1 and Q2 like this, symmetric, D1, D1 distances away, and the particle that I am moving is somewhere over here along the y-axis. And I can have this negative, and that negative, all negatives. And if I ask you to find the minimum value, where would that be still?
The origin.
Still at 0 because you have negative, 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 and then you have repulsive forces at the origin and they will cancel out. And if I ask you to find the maximum value, what would you do?
It would be the same process, but now we would be using sine instead of cosine.
And what would the derivative be? Is it still df by dx?
No, it would be df by dy.
That would be df by dy because I am changing the y. I'm changing the y, not x. So the derivative here would be df by dy on the net y value, not the x value, and we are setting it equal to 0. This is just a hint for your exam. So if I were you, I would write it down, draw this, and put a big star right next to it and say study or practice, something like that. And then number 34. Now, I know that some of you are not talking and you can still send me text messages. I know some of you are doing that also. But if you have any questions, if you want me to slow down or go back to the previous page or whatever, just tell me. And then here again the figure shows electrons 1, 2 on an x-axis, and charged ions 3 and 4 of identical charge negative q and at identical angles theta as shown in this picture. Electron 2 is free to move. The other three particles are fixed in place at horizontal distances r from electron 2 and are intended to hold electron 2 in place. For physically possible values of q less than or greater 5e, I mean smaller than equal 5e, what are the smallest, second smallest and third smallest values of theta for which electron 2 is held in place? You may need a little time to read this and understand what's going on. And I have boxed that q less than or equal to 5e. Now, what are the values q can take? What are the values q can take? Yep. You can text me on the chat. I'm directed to me, not to the class. Oh my God, you did. You did that. Never mind. Yes. So Bree gave the right answer. So q less than or equal to 5e. We talked about charge being quantized in the last class, right? If it is not the case, then we can take infinite number of values. But since it is quantized, all what you can take 1e, 2e, 3e, 4e, and even 5e. Because the charge can be equal or less than 5e, right? Since it is quantized, you cannot really have fractions of an electron. Therefore, you have to have the whole numbers, and those are 1e, 2e, and all the way to 5e. Now, when it says that the charge 2, electron 2, the second one over here, charge 2 is held in the same place. Held in the same place meaning what? I would like all of you to respond to this question. Everyone in the class. If the charge 2 is held in place, what does that really mean? No talking, just send me a text. What does that really mean when you hear that? I'm still waiting for... I'm still waiting. I don't have all the answers. Well, yeah. So here I'm going again. The question says that electron 2 is held in place. What does that mean? How do you have the electron 2 in place without letting it to move? I'm still waiting for a couple of students to answer the question. All right, so here are the answers without names. First, I have an answer which says balanced out forces. Then I have an answer which says the system is at equilibrium. Then I have an answer, the net force is 0. Then I have an answer, the electron is stationary and cannot move. And I have an answer, forces are acting against it. And then I have forces on the electron are in equilibrium. Yeah. So I think you all have an idea about what's going on. So balancing out forces or having the net force equal to 0. Those are the lines that along the lines that I am looking at this, because we are looking at electron number 2, and there are three other charges around it. So we are expecting 3 forces acting on the second charge or electron 2, and then they have to balance out. Balancing out, in other words, is having the net x component of the force 0, net y component of the force 0, and overall the force on the charge is 0. That's what we are looking at, right? And also here we have the same situation as before. The equilibrium is there. So the forces that are coming out, are they at equilibrium? They are, right? Yeah. So the y component forces are going away, and all what we are looking at are net x component forces. All good? So I'm going to quickly draw this and just write down the equations, and I'm going to show you to find how to find the first force, because it says that what are the smallest, second smallest, and third smallest values of theta. Theta is not given, so let's find it. And 34, and there you have these are not solid lines. Negative Q, and here you have negative electron, and there you have a negative electron. And then I'm going to write this as 1, 2, and 3, 4. Yeah. And this is theta, and then Q can be 1 electron, 2 electron, 3 electron, 4 electron, 5 electron. Those are the values Q can get. And the distances are given from here to here, R, from there to there, R. And then if we drew the free body diagram, that's easier. Actually, I did it wrong. So let me cut it off. And this is my charge 2. There you have a repulsive charge because negative repelling, F2, 3. And then again I have that. This is F2, 4. And then I have another charge over here, again repulsive. There you have F2, 1. And the theta angle, this was theta, therefore this is theta, that's theta, that's theta. So charge 2 is in place. Therefore, Fx equals to 0. Sum of Fy equals to 0. Also, by symmetricity, F24 equals to F23. And then I am going to write F24, the equation for F24. That would be Q2, Q4 over R square. And what is R? This is the the picture that we have. This is the little r distance between. This is r, that's theta. Can you tell me what the little r is? Again, use the text chat box. And only to me. We don't have any numbers. We know big R and we know theta. I mean as theta. Theta as theta and the big R as big R. Yep, that's more like it, Bri. Yep. Well, I mean, what I am expecting is the little r in terms of big R and theta. How do you write that? Good. We did something similar in the last problem, but last problem had numbers. Like the values given to us. Okay, so to save the time, I'm going to write it. So cosine theta, let me write cosine theta. Cosine theta is going to be big R over little r, socket over, and then the little r is big R over cosine theta. Right, so my F24 is K Q2 Q4 over R over cosine theta, that. F24. And then on the other hand, I need F21. F21 is pretty straightforward. K Q2 Q1 over R square. Now, by symmetricity, sum of Fy equals to 0. That's clear. I think everybody understand that. And now I am going to write down sum of Fx. Sum of Fx is F21 cosine 0, F24 and F23. Look at the force diagram, free body diagram. F24, which quadrant is it in?
Two.
Second quadrant. What about F23?
Third.
Hello, others? F23
I
is in
agree.
the third quadrant, right? F24 is in the second quadrant. F23 is in the third quadrant. And what can you say about cosine in the second quadrant? Positive or negative?
Negative.
Okay. F23, it's in the third quadrant. Third quadrant cosine is also negative. all students take calculus. Remember, first and the fourth quadrant cosines are positive, but the second, third cosines are negative. Therefore, I'm going to write negative F24 cosine theta, negative F23 cosine theta. Since 2, 4 and 2, 3, they are equal, I'm going to combine the two and write F21 cosine 0 here, which is actually 1. Cosine 0 is 1. 2 times F24 cosine theta. Since cosine 0 is 1, here I have F21 minus 2 times F24 cosine theta. And the next step is substituting for F21 and F24. And after substituting that, we have to set it equal to 0 because we said charge 2 is in place. If charge 2 is in place, both fx and fy must be 0. By symmetricity, we already know sum of fy equals to 0. We found sum of fx, and now the next step is setting it equal to 0. So let's substitute. Sum of fx equals, okay, charge. F21 is k, Q2, Q1 over R square, and 2 times F24 is K, Q2, Q4 over R over cosine theta square times cosine theta. Don't forget that. I'm substituting. This is direct substitution. So I am setting the sum of fx equals to 0 because Q2 is in place. Don't forget that. In place, no net charge. So let's substitute K, Q2, Q1 over R square minus 2 K, Q2, Q4. Cosine square theta in the denominator comes to the numerator as cosine cube theta. And down here you have R square. And that equals to 0. So the things that we can cancel out. K cancels out. Q2 cancels out. They are all non-zero values. R square cancels out. And that leaves us with Q1 minus 2 Q4 cosine cube theta equals to 0. And cosine cube theta equals Q1 divided by 2 Q4. Now what is Q1? Q1 is E. What is Q4? Q4 can be E, 2E, 3E, 4E, and 5E. So you can find the theta, cosine theta, or theta, substituting for Q4 the values. First substitute E, then substitute 2E, and then substitute 3E, and find what you get for theta. And that's basically what the question asks us. For physically possible values of Q less than or equal to 5e, what are the smallest, second smallest, and third smallest values of theta for which electron 2 is held in place? How do you like that problem? So the last couple of problems, those are different, and those are the things that you should be expecting in your exam. And if you are having any difficulty understanding taking components, that's physics one. I mean, other than just like reminding the force components in the first, second, third, fourth quadrants, and this all students take calculus, there's nothing much we can do. So cosine cube theta when Q4 equals to E, cosine cube theta becomes half. So theta, cosine theta is the cube root. And then you can find the theta. And you can do the same for 2E and 3E. Cosine cube root, right? You have to take the cube root of whatever you are ending up on the other side. The e's cancel out. And if you are wondering why I didn't use the negative e and negative e, in the final equation, well, that's because I already took into account that they are repulsive forces. So I don't have to put again the negative sign. So yeah, so that's why I didn't do that. Now that's all I want to do for this chapter. And for the, I'm going to stop the video here.